All right, we're in the home stretch of this first. I guess we could have called it almost experimental section, but hopefully it's been working out decently. So we're on number 17. Number 17, and it says if a plus 2 times x plus 1 is equal to s, what is x plus 1 in terms of s and a? So x plus 1 is essentially equal to what? So let's just take this equation. A plus. So what happens if we subtract a from both sides? Well, we get 2 times x plus 1 is equal to s minus a, right? I just subtracted a from both sides. Let me switch colors. And then if we divide both sides by 2, we get x plus 1 is equal to s minus a over 2. And I think we're done. That's it. That was choice B. And it was actually surprising to see a problem that took so little time this late in the test, because they normally get kind of harder as you go through. And I guess the reason why this is a little tricky is a lot of people's initial motivation would be to try to solve for x and then try to figure out what x plus 1 equals. But the trick is to just not break apart this x plus 1. I mean, you could kind of view this as a variable. Once again, like a couple of problems ago, where you have to avoid distributing this 2 out. If you just keep it as x plus 1 and you solve for x plus 1, you get very quickly to s minus a over 2, which is choice B. The next problem, number 18. We are in the home stretch, and this is normally when the problems get on the difficult side. So let me clear this because this looks like it might take some space. Image invert colors. So shaded region above. So let me draw the shaded region above. So let me see. That's the y-axis. Oh man, I want to draw it straight, but anyway. I'll deal. Can't always be perfect. So this is the y-axis. This is the x-axis. And then I have this neat looking curve. It looks something like this. Something like this. All right, the curve keeps going. And let's see, it draws off some points. So it's like, 1, 2, 3, 4. And then it draws this boundary line here. It draws this boundary line at 4. So it's like this. And then they shade the region, and I have a feeling they're going to ask about the shaded region. So let's also, actually let me, because I'm going to use the shaded in tool. So let me make sure that I don't end up filling up the whole screen. So I want to make sure that I close all the gaps. So now let me use the shaded in tool. Shaded in tool. Ah, there, it worked out. All right. So what are they saying? The shaded region in the figure above. The shaded region in the figure above is bounded by the x-axis, that's this. The line x equals 4, that's this line, right? And the graph y equals f of x, that's this. That's the brown line. Y is equal to f. I never use gray. Maybe I should use gray sometime. No, I don't like gray. Anyway, green. If the point AB lies in the shaded region, so we don't know where, it's someplace in this. Let me use a darker color. Let me use navy blue. This point AB is someplace in this shaded region. Which of the following must be true? And they have choice number 1. And now I have to use a lighter color. Choice number 1 is that A is less than or equal to 4. Choice number 2 is that B is less than or equal to A. And choice number 3 is that B is less than or equal to f of a. F of a. Interesting. So we know that AB is in this gray region, so it's someplace, around there. So if that's AB, so that means at this point, and it's not exact. AB could have been anywhere in this gray area, but let's say that this point is A, and we know that this point, if we just draw here, is B. So we know a couple of things. We know that A is someplace between 0 and 4, right? We know A is someplace between 0 and 4. So that means that a is less than or equal to 4 because it can be it could be 4 because we're including the boundary. So this is correct. We know this is true. Let's see. We also know, well, we don't know whether, let's see, b is less than a. How can we come to that conclusion? Because, I mean, if we had the point that was like right, well, even where it's here, but if, let's say this point, let's say that this point was our AB, then, I mean, just eyeballing it, just looking at the graph, it just looks, I mean, we don't know. I mean, it looks like B in this situation would be larger than A, right? So I definitely don't think we can make that conclusion. At least there's no obvious way to make that conclusion, right? B could, because we don't know what f of x is. F of x could be, really steep and have a really high slope, in which case B would grow faster than A at this point, earlier on. So I don't think that this is right. So this is not right. And then let's see, is B less than f of A? So what is f of A? If this is point A, what is f of A? Well, f of A is going to be right here. This is f of A. Right? This is f of A. And no matter where you draw it, B is definitely going to be less than f of A. If you picked this as our point, right? And if you said that this is B and that this is A, then this would be f of A. This would be f of A in bloody red. And B would still be less than f of A, right? Because B is in the shaded region that is less than f of A, essentially. So we also know that this last term is correct. Hopefully that makes sense. If this one doesn't make sense, I want you to experiment with it, and you'll see. But we're essentially saying that the point is it's all the y values less than f of x, right? This is the shaded region, essentially. So let's see, what choice is that? 1 and 3. 1 and 3 only, that is choice D. D as in dog. All right, number 19. I don't know if we're going to have time for this. Might have to do it in the next video. Actually, let's just do it in the next video because I have 2 more problems, and I'm going to have another video no matter what. So I'll see you in the next video.